We're going to walk through how to evaluate two definite integral examples using U-substitution. To make things easier, I've listed 5 simple steps that we can follow to make U-substitution easier, and we'll walk through these steps one by one as we walk through both examples. In our first example, we are going to integrate the square root of 3x plus 4 from 0 to 7. Our first step is to choose what we're going to let u be equal to. Our first choice should always be to make u equal to the function whose derivative is in the integral. I'm going to let u be equal to 3x plus 4. And then in step 2, we're going to calculate du and solve for dx. Du is equal to 3 dx. And that gives us that dx is du all divided by 3. Our third step is to substitute dx back up into our integral and rewrite it in terms of u. I'm going to not include the 0 and the 7 just for this step. We have the integral of the square root of 3x plus 4 dx is the integral of the square root of u. Here's u. And now we're going to plug in dx. dx is du over 3. And let's go ahead and let's rewrite this as 1/3 the integral u to the 1/2 times du. Our fourth step is to find the limits of integration in terms of u. So let's write down again what u is. U is 3x plus 4. Our original limit of integration started with x is equal to 0. If we substitute that into our expression for u, we get that u is equal to 0 plus 4, which is 4. And then we do the same thing for our upper limit of integration, x is 7. This gives us u is equal to 3 times 7 plus 4, which is 21 plus 4, which gives us 25. In step 5, we are going to integrate our new integral. Now we're going to put back in limits, but now they're going to be in terms of u. U is going to go from 4 to 25, and our integral is 1/3 u to the 1/2 du. That 1/3 came back inside. Now we'll go ahead and pull it to the outside. This is 1/3 integrating u to the 1/2. We're going to add 1 to 1/2, so we get u to the 3/2, all divided by 3/2. And we're going to evaluate this from 4 to 25. Let's first simplify our constants. The 2 comes up on top, and we have 2 3's on the bottom, so this is 2 over 9 u to the 3/2 from 4 to 25. This gives us 2 over 9 times 25 to the 3/2 minus u evaluated at our lower limit, which is 4. So this is 4 to the 3/2. Let's see what this gives us. This is 2/9. 25 to the 1/2 is just the square root of 25, which is 5. So we have 5 cubed minus the square root of 4, which is 2. And that gives us 2 cubed. This is 2 over 9. 5 cubed is 125. And then 2 cubed is 8. So this is 2 over 9. 125 minus 8 is 117. 9 goes into 117. Do you know why? Let me tell you about this real quick. If you take 117 and you add up the digits, you get 1 plus 1 plus 7, which is 9. And that's divisible by 9, so you know that 9 goes into 117. I just think that's a fun trick. This gives us 2. 9 goes into 117 13 times, and we get an answer of 26. Remember, whenever you are computing a definite integral, you're always going to get a number. Let's now look at our second example. For this one, I wanted to do a trig example, and this one is definitely complicated. To choose u, we want to let u be the function whose derivative is in the integrand. Notice that we have a complicated expression involving sine x, and then we have a standalone cosine x. That standalone cosine x can be our derivative. So let's let u be equal to sine x, and let's just see what we get. For our second step, we're going to find du. Du is equal to cosine x dx, and we're going to solve for dx, and we get dx is equal to du divided by cosine x. Let's now substitute this back up into our integral. We're not going to worry about the limits right now. And we're going to write this as the integral of cosine x times sine of sine x, which is now u, times dx, which is now du, divided by cosine x. Because we chose u properly, our cosines cancel out, and we just have the integral of sine u du. So our choice of u was a really good one. For step 4, we have to find our new limits of integration in terms of u. So let's write down u is sine x, and we're going to let x be equal to 0 first. This gives us u is sine of 0, which is 0. And then we're going to let x be equal to pi over 2. This gives us u is sine pi over 2, which is 1. So when we're integrating in terms of u, we're going to integrate from 0 to 1. Our integral is the integral from 0 to 1 of sine u du. This is equal to minus cosine u, and this goes from 0 to 1. So we have minus cosine 1 minus a minus cosine 0. Cosine 1, we just have to leave as cosine 1. So we have minus cosine 1 plus cosine of 0, which is 1. And we get an answer of 1 minus cosine of 1.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.